Welcome back to Mr. Slover's Math. Today we're talking about systems of equations again, and this is day 2 of graphing a system. You're going to be able to solve a system of equations by graphing, so we're just going to do some quick review on how to graph. You're identifying the slope and the y-intercept, and then you're graphing. Same thing on this one. So the slope, remember, is the number attached to the x, and then the y-intercept is the number after it. So I start at -2 on the y-axis. I go down -2, put a point. My slope is 1 over 5, so I go up 1 over 5. Similar for letter B. Number 2 says, draw an example for each type of solution. We saw this yesterday for the first time, so you may or may not quite remember it. Your drawing or your answers could vary. This is just what I came up with. So if we have one solution, you just have two lines that intersect once. If you have no solution, you have parallel lines, which means these lines do not intersect. And if you have many solutions, that means it's the same line. So one line is red, one line is blue, and they are the exact same line. Today, we're going to get into actually graphing both equations onto your graph. So it says steps to solve a system. Number 1, graph both equations on the same coordinate plane. Use a straight edge when you graph them. Accuracy is going to matter. You can use your ID as a straight edge. The second step is to determine a point, if possible, because sometimes your lines don't cross. So determine a point where the linear equations intersect. So there's your 2 steps in order to get your answers. So example 1, and throughout the notes I tried to highlight what went with what. So the yellow information all goes together, the orange all goes together to try and help you identify what piece of information went with what. So for all of this, it says solve each system of equations by graphing, identify the slope and y-intercept, and provide a solution. So the top one, identify my slope and my y-intercept, and then I graphed it. Started at 10. On the y-axis, I went down 3, right 1, down 3, right 1, and I just kept going. The more points you have on the line, the more accurate your answer will be. Okay, so don't stop after 2 points. Keep going. I would suggest putting at least 5 points, if possible, on each line that you create or more. The second equation, y equals x minus 2. Has a slope of 1. Remember, if there's no number in front of that x, it's assumed it's a 1. So my slope is 1, and my y-intercept is -2. So I start at -2, and I go up 1 over 1, up 1 over 1, and I keep going. And eventually, the 2 lines do intersect. They intersect at 3, 1. So I have one solution, and they're intersecting at 3, 1. This needs to be an ordered pair because they do intersect. Anytime you have one solution, which we have one solution, it will be an ordered pair. Letter B, same idea. So yellow goes with yellow, orange with orange. I went ahead and I graphed it. I tried to put as many points as I could on it to make my lines very accurate. You should do the same. And then I have that they intersect once. There is one solution, and I want to know what that solution is. Well, that would be, I went right 4 and down 2. So that's how I got a solution of 4, -2. If I were to take 4, -2 and plug that or substitute that information into these equations, it would make both of them true. That's what that solution is indicating. And then letter C. I have y equals x minus 3 and y equals -3. So that bottom one, the y equals -3, is a little bit different. There is no x value. There's no x variable. It just says y equals -3. So that should be ringing a bell in your head that, oh, this is a special type of line. Well, in fact, it is. It's a horizontal line. So my slope is 0. My y-intercept is -3. So I'm going to count down 3. I'm going to go down 3 on the y-axis. I want a horizontal line, which means I'm going left to right. And the other one I already graphed. Where they intersect is my solution. So there's one solution. They intersect once. That one solution is 0, -3. So remember, you got 2 steps in order to solve a systems of equations by graphing. You got to graph them. So put both equations or however many equations you have on the same graph, and then determine a point, if possible, where the lines intersect. In today's lesson, everything had one solution, okay, but that's not always going to be the case. So if you have any